So we're now going to be looking at stem and leaf plots. So the learning objective here is to be able to construct a stem and leaf plot, which does include the back-to-back stem and leaf plots. Your success criteria will be that you can understand why we create stem and leaf plots, that you'll be able to create a stem and leaf plot which includes all the important features of a stem and leaf plot, so for example, the key, the stem, the leaf, and that you'll be able to create a back-to-back stem and leaf plot as well. So just going through some brief points about a stem and leaf plot. Stem and leaf plots are actually used to organize data. Now we can also use it to display two related data sets, and that's what we call back-to-back stem and leaf plots. And we separate them into a stem and a leaf. Now this is the important information here. The stem includes all but the last digit of a number. So highlight that now so that you're reminded that whenever you're writing your digits in a stem, it includes all but the last digit of a number. The last digit of a number is actually written in the leaf. So now let's try and put this theory into practice, because it does obviously make it a lot easier to understand a stem and leaf plot when you see one being drawn up. So let's consider the data values. So we've got numbers 15, 16, 21, 23, 23, 26, 26, 30, 32, and 41. Now, if I were to set this up as a stem and leaf plot, we would do the following. So the first thing I would do is order my numbers from smallest to largest. Lucky for me, the data has already been put in increasing order, so I'll just write the step down. The reason we do this is because we want to create an ordered stem and leaf plot. That's going to help us to be able to actually look at the data and know exactly what we're looking at in an orderly manner. So then what I'm going to do is actually draw my stem and leaf. So what I would do is draw a line going down and then another one going across. So on my left hand side, I'm going to call that my stem. And on the right hand side, I'm going to call that column my leaf. Now, if we go back to what I said earlier, the stem includes all but the last digit of a number. So for example, if we took the number 15, 1 would be in my stem and 5 would be in my leaf. And that's because the leaf contains the last digit of a number, which means the 1 would go in my stem. So for example, if I had 216, the 6 would be my leaf, and that 21 would be in my stem. So now coming back to this example here, so let's take a look at the data. So we've got 15, 16. So the stem includes all but the last digit of a number. So if we take a look at 15 and 16, they have a stem of 1 in common. So I'm going to write 1. I'm going to write my first leaf as 5, my next one as 6. Then I'm going to look at my next set of numbers. So I've got 21, 23, 23, 26, 26. All of them have a common stem of 2. So I'm going to write 2 in my stem column. And then I'm going to write these numbers. So 1, 3, 3, 6, 6 in my leaf column, but I'm going to do them in an ordered manner. So I'm going to go from smallest to largest. So I'm going to write 1, 3, I'm going to write 3 again because we had two 23s. I'm going to write 6 twice because we had two 26s. Then looking at my next set of data, so I'm going to tick those off because we've written them into a stem and leaf plot. My next set of data was with a stem of 3. So my leaf here is going to be 0. My next leaf will be 2. And then my last stem is going to be 4. And my leaf is going to have 1. Now, just to reiterate here, if we look at this number here, so let's say we look at 41, so that 4 corresponds with the stem of 4, and then that 1 represents that 1 in the leaf. Now, this is why it's really important for you to also have a key as well, because the key is going to help us identify or show the place value of the stems and the leaf. It's also going to let us know what data we're actually looking at. So for example, let's say that the data value 2, 1 represents 21 people. Now, with this particular question, I haven't actually specified what this data is, so we're just going to pretend that it represents people. Obviously, make sure that your key reflects the data values given to you and the context in which it's been provided in. So now what we're going to do is actually apply this understanding to back-to-back stem and leaf plots. So Muji wishes to track the number of blue pens sold over a 10-day period at their Chadstone store and their Melbourne Central store. So what we can see here off the bat, we're comparing two bits of data. So pens sold at Chadstone, pens sold at Melbourne Central. The data is as follows for Chadstone and for Melbourne Central. Now, we've been asked to draw a back-to-back stem and leaf plot, but if you take a look at the data that I've given you, none of it's in increasing order, right? So none of the figures are in any particular order, they just are stated as numbers. So the first thing I would do is actually order the data for each shop. So now that we've ordered the data, let's have a go at actually recording our sales figures. So what we're going to do first up is I'm going to draw my stem and then I'm going to draw two lines around it. So this here will represent my stem, this side will represent my leaf, and the left-hand side this time is also going to represent my leaf. So what I'm going to do here is actually put down that the right-hand leaf is going to represent Melbourne Central. And the leaf on the left-hand side is going to represent Chadstone. So this will help anyone looking at our data to know exactly what they're looking at. So I'm just going to lengthen my stem, looking a little bit narrow. So now if we take a look at our first bits of data, we've actually got single digits. So what I'm going to do is in my stem, I'm going to write the number 0. So looking specifically at Chadstone first, my single digits are 3 and 5. So I'm going to write 3 and 5. So it's going in increasing order from right to left. Now looking at Melbourne Central's data, we've got 6, 6 and 7. So on my leaf, or in my leaf, sorry, for Melbourne Central, I'm going to write 6, 6, 7, because our data is going from smallest to largest, so from left to right. Now I'm going to write my next bit of data for Chadstone. So we've got 10, 12, 14, 15, and 17. So in my stem, remember we're writing all but our last digit in our stem. Being that they're double digit numbers, so I'm going to write 1 in my stem. So then I'm going to do that for 10, 12, 14, 15, and 17. So I've just recorded that data now. And then I'm going to go into Melbourne Central and look at my data in the 10s. So 13, 15, 18, and 19. Given that I've written my stem, I'm going to write the last digit of those numbers. So that's 3, 5, 8, and 9. So now I'm going to do my next stem, which is for the 20s. So again, a stem of 2, which will mean for Chadstone, I've got 1, 2, and 5. And then for Melbourne Central, I've got 1, 3, and 5. Now again here, what you can see is that we're able to compare the data. So now I'm just going to write here that 0, 6, 6 pens sold. And that's my key. So that tells anyone looking at my stem and leaf plot what exactly the data means in that stem and leaf plot. Now what we can see here is that Chadstone and Melbourne Central, have sold quite a number of pens. If anything, it's kind of looking more like Chadstone actually sell fewer pens than Melbourne Central, and this is just given by the way the data is distributed. Obviously, we would be looking at the mean, median, mode, and range as well to help us make that decision, but that's something we'll be looking at in the future. So that's it for stem and leaf plots.